In this video I will solve a numerical problem set 7. The first question is, what is the minimum size of particle that will be removed with 100% efficiency from a settling chamber under the following conditions. So what are the given conditions? Viscosity of air, it is 2.1 into 10 power minus 5 kg per meter second. Then horizontal velocity of air, horizontal velocity of air is equal to 30 centimeters per second. Particle specific gravity is equal to 2.0. Chamber length is equal to 7.5 meters, and height of the chamber 1.5 meters, and it is asked to calculate the particle size for 100% efficiency. So it is given by the solution. So it is diameter of the particle with 100% efficiency. The formula is under root 18 mu h by GL rho p. So where just substitute the values. 18 into mu is the viscosity of air, that is 2.1 into 10 power minus 5, into h is the height of the chamber, that is 1.5 meters, into VH is the horizontal velocity of air, that is 30 centimeters per second, which is 30 centimeters per second means 0.3 meters per second, divided by G value 9.8 into L is the length of the chamber, that is 7.5 meters, into rho p, that is density of the particle. So since specific gravity is given, we can calculate the density of the particle, that would be 2000 kg per meter cube. So this will give, if we just do the calculation, you get around 34 into 10 power minus 6 meters, this is 34 micrometers. Next, let's go to the second question. A cyclone separator has following body dimensions. What are the values? Body diameter D is equal to 1 meter, height of inlet is equal to 0.5 d, width of inlet is equal to 0.25 d, length of the cone is equal to 2d, and length of body is equal to 2d. Further, it is given the flow rate of air particulate mixture is 150 meter cube per minute. Density of particle is 1600 kg per meter cube. And further, density and viscosity of air are 1.204 kg per meter cube and 1.81 into 10 power minus 5 kg per second. Calculate overall collection efficiency. Particle size distribution is given. Particle size distribution as follows. So the particle size distribution, okay. So particle size dp and then mass fraction of that particular size range. Okay. So percentage of mass in size range. So what are the sizes? 0 to 2 micrometer. So let's see, all of them are in micrometers only. 0 to 2, then 2 to 4, then 4 to 6, 6 to 10, then 10 to 18, 18 to 30, 30 to 50, and 50 to 100. So these are the size ranges, and how much mass is there in each size range? So here it is 1%, it is 9%, and then it is 10%, 30%, 30%, and 14%, and 5%, and 1%. Okay, now we have to calculate the efficiency. For calculating efficiency, first we need to calculate the cut diameter. So the cut diameter, it is given by, because efficiency formula is eta is equal to 1 by 1 plus d cut diameter by any, maybe for size range j, dj whole square. So we need to calculate first cut diameter. So d cut diameter is given by the equation 9 into wi mu by 2 pi and vc to rho p whole power 1 by 2. So now we have to list out what are the values given. First we need wi. So what is wi? Wi is the width of the inlet, that is given, which is 0.25 meters. Then mu value is given, which is viscosity of air, which is 1.81 into 10 power minus 5 kg per meter second. Then we have Ne. Ne is number of turns, number of effective turns. This is given by the formula 1 by h into length of the body plus length of the cone by 2. So if you substitute the values, what is the height of the inlet? That is 0.5. Length of the body is given, it is 2, and length of the cone is also given 2 by 2. So this would be 6. So 6 is the number of effective turns. Then we need Vc, that is velocity of air at inlet, and it is equal to actually we are not given with the velocity of air, but we are given with the volumetric flow rate. So if we have the volumetric flow rate Q, if we divide it by area, that is WH, we get the velocity of the air at the inlet. So what is the value of Q? Q value is 150 divided by width is 0. What is the value? So width of the inlet is 0.25 into height is 0.5. So we get, if you substitute, you get around 20 meters per second. So that is so once we calculate the number of effective turns, then velocity of air at the inlet, it depends upon the volumetric flow rate and the inlet area. So volumetric flow rate is 150 divided by inlet area is width into height, so 0.25 into 5, we get 20 meters per second. So now we know the density of particle also, because it is given density of particle is equal to 1600 kg per meter cube. So now we just have to substitute these values to get the cut diameter. T cut is equal to 9 into Wi. Wi is 0.25. 0.25 into mu, viscosity of air 1.81 to 10 power minus 5 divided by 2 into by 3.14 into a number of effective turns is 6 into velocity of air at inlet, that is 20 meters per second, into density of the particle is 1600. If you substitute all this, you get around 5.8 into 10 power minus 6 meters, or you can say 5.8 micrometers. So now we got the cut diameter. We need to calculate the efficiency. For calculating efficiency, different sizes will have a different efficiency. So if we look at the distribution given, so size range is given, but we need a single diameter to calculate the efficiency. So for each size range we calculate the average size. So average size would be like, if the size range in 0 and 2, 0 to 2, then 0 plus 2 by 2, that is 1. This is the average size. This is in micrometers. So for 2 to 4, 2 plus 4 by 2, that is 3 micrometers. For 4 to 6, 4 plus 6 by 2, 5. 10 plus 6 by 2, 8. 10 plus 18 by 2, that is 28 by 2, 14. Then 30 plus 18, 48 by 2, 24. Then 30 plus 50 by 2, 40. And so 75. So now we have average size. We use this average size, let's call this J. So we can substitute in the efficiency equation, this equation. We know the cut diameter. We use this calculated average size. This Tj would be the average size. If you substitute, you calculate the efficiency for each range. So if you just do the calculation, you get the efficiencies. So you should get the following values. Efficiency for particular size range would be, for the first one it is 0.029, next one is 0.211. For this you just substitute, you should get these values. 0.655, 0.854, 0.945, 0.979 and 0.994. So now we have Nj values. What we have to do, we have to take an average with weight from the mass fraction. That is, we have to calculate the mass fraction. Let's call this as, let's say, Wj, mass fraction. Then we just have to multiply Wj into Nj. Then we have to take a summation. So we have to take, so what we have to calculate is, we have to calculate the average, or you say overall efficiency. is equal to summation over j, that wj values and nj values. So for example, for the case of first one, so the wj value here it is 1% means 0.01. For here 9% means 0.09, 0.1, 0.3, 0.3, 0.14, 0.15, 0.1. So now you multiply this wj with nj, so you get 0.00029. Likewise, we have to calculate wj nj and then take the summation. You get the average value. So that value wj nj, this would be you can say 0.01 into 0.029 plus 0.09 into 0.211 plus 0.1 into 0.426 plus 0.3 into 0.655 plus 0.3 into 0.854 plus 0.14 into 0.945 plus 0.05 into 0.979 plus 0.01 into 0.994. So if you calculate this sum, you should get value around 0.706, or you can say 70.6%. Okay. So this is the second question. Next, let us go with the third question. Third question is pretty much same as the second question. Only thing is you don't need to calculate for the entire distribution. You just have to calculate for particular given size. Okay, the third question is a cyclone separator has an inlet width of 10 centimeters and 4 effective turns. The gas temperature is 350 Kelvin and the inlet velocity is 10. The inlet velocity is 10 meters per second. The average particle diameter is 8 micrometers. The average density means it corresponds to density of particle. Average density of particle is 1.5 gram per centimeter cube. So it is asked what is the collection efficiency. So the viscosity of air is given. The viscosity of air at 350 Kelvin is 0.0748 kg per meter hour, and so neglect density of air compared to density of particle. Okay. So just now we have seen in our previous problem, the efficiency is given by 1 by 1 plus d cut by density of, maybe you can say any particle size, density of particle whole square. So now we have to calculate d cut, that is 9 nu w by 2 pi number of effective turns into velocity of the air at inlet and into rho b, all power 1 by 2 or square root. So now the viscosity value, the only thing is here viscosity value is given 0.0748 kg per meter hour, so which means 0.0748 by 3600 kg per meter second. Then we have W, that is 10 centimeters is equal to 0.1 meter. Number of effective turns is 4, and we have velocity is given as 10 meter per second, and density of particle is 1.5 into 10 power 3 kg per meter cube. Just substitute all these in the d cut equation, cut diameter equation. So it would be 9 into viscosity 0.0748 by 3600 into W is 0.1 divided by 2 pi, 2 into 3.14 into number of effective turns 4, and VC velocity is 10 into density of particle is 1500 power 1 by 2. So if you substitute the values, you should get around 7 into 10 power minus 6 meters, or you can say 7 micrometers. So this is the cut diameter. Then efficiency would be, you are given with the particle size of average particle size of 8 micrometers, so it would be 1 by 1 plus 7 is the cut diameter, and particle diameter is 8 whole square. So this would be, should come around 0.56, which means efficiency is equal to 56%. Okay. So next to go to the fourth question. Find the collection efficiency. Find the collection efficiency of horizontal flow single stage electrostatic precipitator consisting of two sections formed by plates of 4 meter wide and 6 meters height on 25 centimeter centers, handling gas flow of 2.5 meter cube per second. Assume that migration velocity is 12 centimeters per second. 12 centimeters per second. So we need to calculate the efficiency of an electrostatic precipitators. So it is like, in general we know, see here the issue is there are two sections, so it means like between the centers and the electrode, the flow rate is being divided. Like initially the flow rate is 2.5 meter cube per second, but this is split into two. Then the area of plate is given. So thing is, the volumetric flow rate is divided between the two before it is coming into the inlet. That is one thing. And the second thing is, total area for the collection now would be this plate area and this plate area. So there will be two collection areas. So that is the thing. So total collection area, that is A is equal to collection area would be area of the two plates. So 2 into area of the each plate, that is 4 into 6. So total 48 meters square. And then we need flow rate, volumetric flow rate Q. So flow rate in each section. So that would be can set originally it is coming 2.5 meter cube per second, but it is divided by 2, so it would be 1.25 meter cube per second. And then we have W, that is migration velocity, is equal to 12 centimeters per second, which means 0.12 meters per second. So just substitute in the equation of the efficiency 1 minus exponential of minus WA by Q. So if you substitute the values, so it will be 1 minus exponential of minus W 0.12 to A 48 by Q. Q is 1.25. So this would come around 99%. Next question, fifth question. Find the migration velocity for an existing electrostatic precipitator with collection plate area 110 meter square, gas flow rate 2.5 meter cube per second, and collection efficiency is 99.5%. So just from the expression we have, that is for electrostatic precipitator, eta is equal to 1 minus exponential of minus WA by Q. So here eta is given, we need to calculate the migration velocity, that is W. So W would be, just rearranging the equation, you get minus 1 minus eta into Q by A. So if you substitute the values, minus ln1 minus 995 into 2.5 by area is how much? 110 meter square. So this gives us W is equal to 0.12 meters per second. Next question, sixth question. The charge acquired by particle of diameter d and dielectric constant epsilon naught in an electric field strength E is given by, so how much charge a particle will acquire in an electric field E is given by Q is equal to 3 pi into epsilon by epsilon 2 epsilon naught into d square E. calculate the charge and drift velocity of a particle of 1 micrometer diameter and epsilon is equal to 6, placed in electric field of strength 300 kilovolt per meter. Assume that Stokes' law holds for the drag force. If the collection plate area is 24 meters square and gas flow rate is 400 meter cube per second, calculate the collection efficiency of ESP. Okay, so we are given with how to calculate the Q, then we have to calculate by substituting those values. We have to calculate the charge, then drift velocity, and then collection efficiency. So first let us calculate the charge Q. So by substituting in the equation, so Q is equal to 3 pi, epsilon value is given, that is 6 by epsilon plus 2 into we need to have epsilon naught, that is 8.85 into 10 power minus 12 coulomb voltmeter into diameter of the particle squared 10 power minus 6, that is 1 micrometer whole square, into what other value, E, electric field strength value is 300 kilowatts, means 3 into 10 power 5 volt per meter. So this, if you substitute, you should get value around 1.88 into 10 power minus 17 coulomb. So now if this much charged particle, if it is placed in an electric field E, okay, so we are told Stokes' law holds. So what it means, like whatever the force experienced by this particle due to the electric field E is equal to QE, but since Stokes' law holds, means this is force is balanced by 3 pi mu d into W, where W is the drift velocity. So W is given by, this is what we have to calculate, W is given by QU. Q is how much? 1.88 into 10 power minus 17 coulomb into E, electric field is 3 into 10 power 5 divided by 3 pi mu d, 3 into 3.14 into mu. Viscosity of air is 1.8 into 10 power minus 5 into diameter 10 power minus 6. So if you substitute the values, you should get answer around 0.033 meters per second. Once we have the drift velocity, we can calculate the efficiency. Efficiency is basically 1 minus migration velocity or drift velocity into A by Q. So A and Q values are given, just substitute 1 minus exponential of minus W is 0.033 into A by Q. A by Q is 24 by Q is 400. So if you substitute, the value you will get is 0.00198, which means plus 0.198% is the efficiency. Okay. So this is problem 6.